In this video, we're going to be solving the LeetCode question, same tree. So what exactly constitutes a same tree in the eyes of LeetCode? Well, if a tree has the same structure and it also has the same values, it is the same tree. And if you look at the examples that I have below here, these two trees are the same. They have the same values, 1, 2, 3. But also they have the same amount of nodes, they have the same amount of children, they have the same shape, and the numbers are also in the same order. How exactly are we going to determine if two trees in memory are the same? Well, there's many ways that we could solve this question. But I'm going to give you a warning or somewhat of a piece of advice. With these very easy tree questions, you should likely stay away from recursive depth first search for one simple, very strange reason. It's going to be too easy. Recursive depth first search is going to be so easy that they're likely going to ask you for the iterative version, which we are about to implement. In this case, we can use either DFS or BFS. It really doesn't matter which one that you use. It just needs to be iterative. So I'm going to use an iterative breadth first search. An iterative breadth first search utilizes a queue. Now, many times people see queue and they start freaking out and thinking that it's going to be very complex, but it's really not that complex. All a queue does is keep track of, number one, where we are at in the tree, and also where we plan on going. And because whenever we traverse any tree, we're always going to start at the root, aka the top of the tree, we're going to go ahead and add both nodes. Now, we need to add both nodes because we need to compare the equivalency of both trees. And whenever we add something to the queue, wherever we dequeue or wherever we pop off, whichever element is deemed to be next to come out of the queue is going to be where we are at in the tree. So we are currently at number 1. And we're going to check whether both of these nodes are exactly the same. And they are. So we're pretty much done. We can continue traversing down our tree. The next two nodes are going to be 2 and 3 because they are underneath our parent. So we're going to add the 2 from this tree, and we're going to add the 2 from this tree, and we're also going to add the 3 from this tree, and we're going to add the 3 from this tree as well too. Now remember, the next two nodes that come off are going to be where we are going to traverse. So we're going to be traversing to 2. When we traverse to 2, we're going to do the exact same thing that we did before. We're going to check if they are the same. They are the same, so we can go ahead and get rid of them. We don't have any other children, so what we're going to do is we're going to go to the next node, which is going to be 3, because 3 is going to come off the queue next. So we're going to go ahead, navigate to 3. We're going to do the same exact thing. We're going to check if they are the same, and if they are the same, we are done. So let's go ahead, let's code this, and let's go into IntelliJ. So we're inside of IntelliJ, and the first thing that I'm going to do is create a Java class, and I'm going to call it TreeNode. We're going to go ahead, just to get some practice in, we're going to create the tree node that we will utilize in this algorithm. And AI is going to do everything for us, so we can just kind of tab through most of this. First thing is we just want an empty constructor, and then we also want a constructor that passes in a val, and I'm just going to call this val to mimic what LeetCode has for us. Now I'm going to go down here and I'm going to do the exact same thing, but in this case, I also need to add a semicolon right here. In this case, we're going to have this val, we're going to have this left, and we're going to have this right. So that looks good. Let's go ahead. Let's create our solution. So I'm going to create a brand new Java class, and I'm going to call this solution. Within this solution file, we're going to house our method for the algorithm, and this method is going to return a Boolean, and it's going to be called isSameTree. And the parameters are going to be a tree node of P and a tree node of Q. let's go ahead, let's do a really quick null check. And if both P and Q are equal to null, what we're going to go ahead and do is we're going to go ahead and return true. Now that we've gotten that pesky null check out of the way, let's go ahead and create our queue. And this queue is just going to be comprised of tree nodes. But very important, remember, before we do any iteration, we need to go ahead and we need to add the root nodes. And we need those root nodes because without those root nodes, this while loop would not trigger. So remember, a queue does two things. It keeps track of where we are, and it keeps track of where we plan on going. And the way that we get where we are currently is we queue.pull, or we dequeue, or you pop it like you do in a stack. We could create brand new variables for this, but I think it's just easier to go ahead and reassign the variables in this case. Next thing, we're gonna do some logic. So this logic is going to check if P and Q are equal to null, but we don't want to return true in this case. We want to return continue, because P and Q equaling null does not necessarily mean that it is not the tree that we want. And this is because in some scenarios, P and Q might be null because there only might be one child. And if there's only one child, it doesn't necessarily mean that the tree is not identical. So that's the reason that we have the continue. Next thing, we're going to check if P or Q are equal to null. And if P or Q are equal to null, that is a definite sign that the tree is not the same. We want to go ahead and return false. Next thing, we want to check if the values are not equal. And if the values are not equal, once again, that is a definite false. And if we get through all of this logic, this means that we're going to go ahead and we're going to continue iterating through this tree. So we're going to say if p.left, so we're going to say add p.left, and we're also going to say add q.left. And it really doesn't matter which order that you add them in, but I'm going to go ahead and do lefts and then rights. And that's going to go ahead and add them to the queue so that we can know where we are going to iterate to next. And that's pretty much it. So let's go ahead. I'm going to grab all this code right here. Going to go ahead, hit that copy button. We're going to get out of full screen mode here. So I'm going to go ahead, bring this on over. Going to toss that into the editor, move that over. Let's go ahead, hit our run button, make sure that all our test cases are running. They are. So let's go ahead, hit that submit button and analyze our time complexity. So time complexity, linear, and our memory is linear as well too. Congratulations, you have passed the interview. Hope that you guys enjoyed this. If you did, make sure to smash that like button, smash that subscribe button. As always, thank you for watching.